Hello, this is Jim Shawless with the Bureau of Geologic Survey. Welcome to Part 3 of the discussion of the mapping project we undertook for Ohiopyle State Park in the greater Youghiogheny River Gorge area. This time we're going to be looking at the Pennsylvanian, Permian, and Quaternary age of rocks. And we're going to be looking at Pottsville, Allegheny, Glenshaw, Casselman, Monongahela, Waynesburg, Washington, and Carmichaels Formation. Now we're going to take a look at the Pottsville Formation with its Homewood sandstone member, which I think is the most important geologic unit in the park, not only for interpretation but for also its importance to recreational activities. Here's the outcrop pattern for the Pottsville Formation in Ohiopyle State Park in the greater Youghiogheny River Gorge area. It's outcropping along the Laurel Hill anticline on both flanks and down where the axis plunges to the south. It's got a nice outcrop area along Chestnut Ridge anticline along the axis, and the most important area is where it's outcropping is along the Ligonier syncline, where it passes through Ohiopyle State Park along the Youghiogheny River. And here's a generalized stratigraphic column for the Pottsville Formation in this area. It's got Homewood sandstone at the top, and then a Mercer coal horizon with upper and lower Mercer coals, followed by conocynessing sandstone, which would be, if there's a Quakertown coal present, we make that the upper, and it would subdivide the sandstone below the coal and make that into a lower conocynessing sandstone. In Sharon coal, I really haven't seen anything down there except maybe for a carbonaceous zone, and so therefore I can't really say I've seen a Sharon sandstone. So it's really in that part of the section it gets to be very transitional to the Mauch-Chunk. Pottsville Formation is about 250 feet thick in most places. Lithologically, it's made up of sandstone, siltstone shale, claystones, and thin coals. Probably coarser grained for the most part, and more massively bedded, and to some extent conglomeratic near the top. As you go down the section, the sandstones are less coarse and thinner bedded. The claystones, siltstones can have siderite nodules in them, and the coals can have brackish zones over them. Depositional environment, I'd say, would be high energy, delta plain to lagoonal. Key beds, I think, Homewood sandstone at the top. It's massive to thick bedded. It's got quartz pebble conglomerate with subangular, sub-rounded pebbles, about 2 to 5 millimeters in diameter. You can see them in the slide right there. It forms ledges, and also you might, if you have a coal with a brackish zone over it, brackish marine fossils, that also could be a good thing to have for correlation purposes. So you can sort of see what I'm talking about here. Here's there's a lower and upper conocynessing sandstone here. They outcrop along the CSX track on the eastern flank of Chestnut Ridge, north of the river, and you can see they're thinner bedded and they are not as coarse grained, so they're not really going to be, I mean, you can confuse them, sure, with the Homewood, but generally speaking, it's not as bad of a problem as you might think. If you got enough section to look at, you can pretty well figure it out. And especially if you look in the lower over here, this like conocynessing, especially in the upper, conocynessing has got a lot of intervals. It's much thinner bedded, and more highly cross-bedded than what the Homewood is. So here we're looking at an outcrop along the CSX track. It's right on strike in the Ligonier syncline. You've got the lower Mercer coal horizon here and the upper Mercer coal horizon. It stays pretty much the same distance above the track for about a mile. Okay, here we're looking at the Homewood sandstone, and it looks to me like near the base of it here you have a lens of coal, and we might be able to interpret this as where the Homewood sandstone came down into perhaps the upper Mercer peat swamp, picked up a bunch of peat, and incorporated it into the sandstone layers near the base of the sandstone channel in this area, and it later then lithified and into the coal seam we see today. Here's an outcrop up along Meadow Run where the Homewood sandstone comes down onto the upper Mercer coal and almost cuts it out. And if we look along Ferncliff underneath the area called Lover's Leap, you can see where it cuts it out again. Let's just take a look at that quick. You see the upper Mercer. It's about 2 feet thick here, and then it starts to get really, really bony looking as it approaches like this area where the sandstone, overlying sandstone, cuts down into it. You can see right in this area, right in here, you have like a bony claystone, and so we lost the coal, and there's some coaly lenses in here, but it's mainly bony claystone. And then the sandstone cuts it out completely all the way down below it. And if you follow the sandstone, look, I tried to find where the coal was in there and I couldn't. It looks to me like it cut completely through it, probably down at least 10 to 15 feet. Hard to see it right here, but look, down in here we're at least 15 feet now below where the coal horizon was. And this is just solid, massive sandstone in here underneath what's called Lover's Leap. So here we're going to look at a little bit more closely at the upper and lower Mercer, and I took a short video tour of that. Okay, we're going to take a quick walk up along the Great Allegheny Passage rail trail and looking at this beautiful outcrop that's exposed along the trail right here. And if you look right down in this area here, that's the lower Mercer coal, and about halfway up is the upper Mercer coal right there. And if you look just above that, that's the Homewood sandstone up there. As we come up around a little farther here, we can see that the Homewood sandstone is cutting right down onto the Mercer coal. And the area in the section in between the upper and lower Mercer is very fine grained. It's got claystones and siltstone, and it's full of siderite nodules. And this represents, I think, a lagoonal kind of a restricted back bay environment in this area, because you have brackish marine fossils in this rock. And the iron ore, or the iron siderite nodules, were used for iron ore during iron making in this time, so that was also an important resource. I'm going to take a quick walk up here and look at the lower Mercer coal, but first I think we're going to stop and look at a big chunk of clay stone that fell out, and it's got siderite nodules in it. Get the leaves off, see them right there. And then we're going to look at some root work clay stones right there. I think that fell out from right below the upper Mercer. And up here we have the lower Mercer coal, and this is like really a bone coal to a bone clay stone. Not much carbon in it, probably a lot of sediment coming into the peat swamp, and didn't get much time to form peat there. Right above it you've got brackish looking, and you got brackish shale, very dark carbonaceous shale. I'm going to try to find some fossils in it if I can. And look around here and see if I can find them. Not seeing any there. Keep digging. Well, it's going to be hard, so we're just going to stop and take a look at it with a slide for you. I'm going to show it to you on a slide. Okay, these are the fossils that I was trying to find in the outcrop for you to show you. These are Lingula, and they occur right above the lower Mercer coal throughout this area, about 7/10 of a foot above the top of the Mercer coal. And that seems to be the case in several outcrops. So I'm going to continue on a little bit down the trail here, and while I was first looking at this, I was trying to map this area, trace the coals around, and so I thought, well, if I can trace and I couldn't get to the upper Mercer very well there because of the steepness of the slope, and there's no access to it, so I was trying to figure out where it went, and I thought, well, if I go over here to Sugar Run, I'm sorry, over here, Teeny Run, and follow up the trail, and I thought, well, it's got to cross Spruce Run somewhere up here, and I can see where the Homeward Sandstone is. I look close to that, and maybe I can look under it and figure out where it is. Well, you can see Sugar Run's just covered with leaves right now. It's dry, but it's covered with leaves. Not like when I was looking at it. It was lots of water flowing across it and really wet. So here we are today. It's real dry, but you can't see much because of the leaves. And but you can see there's a clay stone, and it's thinly bedded underneath the ledge of sandstone. So you got to say, well, where's the coal at? Well, started looking around. I couldn't find it, and then I noticed that there was an opening underneath this ledge, so I just crawled back in there. Sure enough, there's a coal seam that had been undermined, mined out a while back. I don't know exactly when. Had a nice smooth sandstone roof, and had these posts in them. I don't know how good the posts are actually doing right then, but there. And so crawl back around through here, you can get a pretty good feel for conditions. You can see that I think the ceiling is in pretty good shape, but for some reason there's I don't know if the floor is swollen up, pushed up over the years. I can't imagine this is stuff that they spoiled, that they mined out and just left in there, but it's possible, I don't know. But you can look back through here, and you can go back in here a ways. It gets pretty tight, but you can crawl back in, and if you look back and around the corner, it'll go back in there for like 150 feet or more at least, way down in there. And some of the ceiling is falling in down in there, and I can tell, but you can still, I think, get in there, but I didn't really want to go down by myself. I think that was too smart, because I don't know what the, carbon dioxide could be down there, methane, so I said I better not chance it. It looks like it's almost on down dip, but so I started looking around. You can see the ceiling is falling out here, and you can turn around, you can get back out, and coming back out. I can just imagine mining in here. I can imagine if they at least when you get out, you'd be clean anyway, because you could shower off. And there's a nice claystone right underneath the ledge right there. So it's a nice solid gray rootwork claystone, which is what you'd expect under the coal. Here's what it looks like most of the time. So hard to tell that there's a coal seam back in there, but if you were mining that, well, you could come out at the end of the day and get a nice shower, get cleaned off. And here the homewood gets to be the thickest, like I found in the park, which is like it's 85 feet or more, and it's thick in a lot of other places around there too. And it comes right down here in this point and all the way down to the lower Mercer coal bed, and it just doesn't quite go through it, but it's right on top of it. I put together an isopack map showing the thicknesses of the homewood sandstone ledges in the area around the park and the gorge, and it looks like the area, the one I just showed you, is right here on the axis of the Ligonier syncline. That's the 85-foot thick one. But there's also other similarly thick ledges around that area too. And even if you go down in here towards the Cucumber Falls, you'll see it's also fairly thick. But if you go up on the ridges, on the anticlinal ridges, they seem to be pretty thin for the most part. And then you got back down into the synclines again, it starts to thicken up again on both sides. So interestingly, I think this is very similar to what Donaldson found in '74, where he related thick occurrences of sandstone in northern West Virginia and southwestern Pennsylvania to occurring along the synclinal axes, and thinner units would occur above the anticlinal axes. And he inferred that this had to do with growth faults in the area, that there was actually growing structures at that time that the sandstones are being deposited. So you got thicker deposits in the synclines and thinner on the anticlines, and also they lined up lengthwise more along the synclines than they did the anticlines, which, you know, sort of what I've seen. So I put together a outcrop map, trace the homewood sandstone through the gorge area and around the park, and you can see how it hangs right along the Ligonier syncline, where it's right near the level of the river, just on both sides of the river. But as you go over, let's say towards Chestnut Ridge, it starts to lift up and come off away from the river, and same thing holds true in Laurel Hill anticline, as you would expect. Well, the bottom line, the result of that is that around this area, you can see on the right hand side, you got really good rafting. I guess during the periglacial period, where you had a lot of freezing and thawing and slope instability, and you had boulders breaking loose and moving down the slopes, they ended up right here a lot more easily in the river. Plus, in this area, plus once you get up into here, like I showed you before, you got this Burgoon sandstone ledge that prevents the homewood from getting down onto the river. Same holds true over here. So bottom line is, where you got the homewood, you got good rafting. Where you don't have the homewood, well. So here's some examples of what you see out there as far as the homewood. You either have these loose blocks laying around on the landscape, or you have these big ledges that like occur along either side of the Ligonier syncline. It's not uncommon to see well-defined siderite bands near the top of the formation. It's also not uncommon to see differential weathering on the surface, where some of these quartz-rich layers stand out in relief. And you also often see this like Ophir Kessel weathering. On some of the ridges, it gets to be deeply weathered and gets these big pockets weathered out in the surface. This exposure of Homewood sandstone is near the top of Laurel Ridge in Ohiopyle State Park. And a similar exposure, not too far away, Frank Pizzaglia did beryllium-10 testing and got an age date of about 202,000 years. This may indicate that it takes a while to create that kind of deep weathering. And I saw this interesting pattern on the top of the Homewood in this one area. It looks like you got a lichen or a moss growing on it that's contributing to the pocketed weathering that you're seeing on the surface. And here I found this interesting boulder. It was on State Game Lands 111. This would be on the Laurel Ridge anticline on the western flank of the anticline. And anyway, I noticed that there's a lot of these really deep weathering features where there are pockets and holes in it, and I just wonder if they're not related to maybe carbon in the rock, because you have iron carbonate, of course, of the siderite, and you also have plant debris and material in there. And could that be that the carbon is sort of weathering and you're getting carbonic acids being formed, and perhaps the clay minerals that are helping to cement the rock together are forming sulfates, and those sulfates then maybe hydrate and expand and break the grains apart. I just wonder, because a lot of the rock shelters I noticed have a lot of plant debris in the roofs of them, so might be some relationship there. And the other thing I found interesting about this rock was it looked to me like, in addition to these vesicles over here, it looks like you got this, looks like a pictolith or some kind of a Indian carving or something of an Indian out there. I mean, I don't know, but it looked like doesn't look natural to me. So it's like, okay, and this sort of serves as a segue for where we're going to go next, which is Elk Rocks. It's a rock city developed in the Homewood sandstone, and it's dead on the axis of Chestnut Ridge. It's also in State Game Lands, number 51. And the reason that it was called Elk Rocks is there's supposedly a figure of elk that was drawn on one of the surfaces of the rocks. And but we're really going to take a really close look at these vesicles over here as well. And here's Elk Rock, and you can see it's sort of like a rock city, and it's got some fracturing, it's got some joint planes in it. If you look over here, it's about 35 feet up and down, a nice joint face on the side. It's got a lot of vesicular weathering in, and the vesicles are sort of elongate up. Here you can see some cross-bedding, external cross-bedding. And we'll just take a quick look at the vesicles here. I think that's one of the most spectacular parts of this rock. Some penny for scale. Oh well. Try it again. There we go. And so they're about 3-4 inches across. Some of these, they vary in size, but they don't get much bigger in a baseball size, and mainly ping pong ball size is about the average. And there's many layers to them. It seems like there can be honeycombed and sort of like boxwork, but it's more I don't think it's related so much to bedding plains. It almost looks like it's more chemical, but there's a lot of taphony type of features here where they're weathered back in deep. There may be some bedding associated with this, I'm sure. I can see bedding lines, but it's like preference there. And some of these blocks, if you look at them, the vesicles and the actual weathered out holes get much larger as you go up closer to the top of the rock, or obviously near the old surface. Here's what I call the Christmas boot, or Santa Claus boot. And if you look at this, you'll see writing all the way around it, and people have carved things into it, so it's obviously pretty soft. And here's obviously Frank Pizzaglia's relative must have been here, but time traveler obviously didn't put the date. Left to be determined. There's Gail's autograph. She was here in '97. And just you could spend all day just looking around at all the different carvings and dates. And this used to be a park. People come up here and dance. This is the main route from like old Route 40 or Lincoln Highway down to Dunbar before they actually had the main road. The wagons came through here, is what I understand. Came past this, and there you can see Elk Rock got its name, probably Red Cloud, I think he drew an elk on here. The earliest date I saw was 1800. So there may be some older, but I haven't seen them. And this is one of the rocks that are out near this edge, and it's like really weathered. So I didn't feel too bad about this, but I said I'm going to try my luck here just with my finger. And you can see this stuff is just like so friable. You can just carve your own name right into the rock just with your fingers, which is okay. Just don't tell the Game Commission, but I do have a research permit, so that's actually just research. And everything, there's buzzards that frequent these ledges, and they raise their young here. I'll tell you, I crawled back in there to get some photographs of these things, and it's the most terrible environment ever to try to raise an animal. That is just bad and damp, and it's dark and it's wet and just nasty. And the Homewood sandstone also has some other creatures that like to hang around it, like the snakes. I'd like to talk about the Allegheny Formation a little bit. And here's a slide showing the aerial extent of the Allegheny Formation, and it sort of outcrops in a belt that runs up along either side of the Ligonier syncline, and then also over on the eastern flank of the Laurel Hill anticline. And the Allegheny Formation in the park was hard to map. The exposures were poor. You needed drilling to be able to determine where the top and bottom of the formation was, and what you're really seeing at in the landscape as far as outcrops go. We did have a drill hole that penetrated the entire formation, sort of in the center of the park. Didn't have an upper Freeport, but we had a Johnstown lime with an upper Quaternary and a lower Quaternary coal, and a Brookville coal with a nice 10-foot thick underclay. So it was very useful for correlation purposes. There are some key beds, you can locate them. The main way to characterize the Allegheny Formation is the upper part contains freshwater limestones. The lower part contains brackish marine zones. the whole interval has coal seams all through it, about every 50 feet generally. But the key beds here would be the lowermost limestone bed and the uppermost brackish marine unit. So the Johnstown lime is the lowest most freshwater limestone in the section, and then right under that you'll find a brackish marine zone above the middle containing coal. Usually it's above the rider coal. If you can find that combination together, that interval, you know exactly where you are in the second stratigraphic sequence. Lithologically, the Allegheny Formation is made up of a variety of different rock types, but in decreasing order of the amount: sandstone, siltstone, claystone, clay shale, coal, limestone, and siderite. As you go down into formation, however, it does get sandier, and it also gets to be more, I'd say, brackish, iron-rich. You got more siderite down there. Higher in the formation is where you encounter the limestones. Depositionally, looking at lower delta plain to coastal, so you've got some influence with those restricted bays with the brackish marine deposits, and like I say, it's more freshwater lakes and things like that in the upper half, so you get somewhat finer grained sandstones, but you do get these lake deposits, which are represented by the freshwater limestones, which would then, they were in lakes and later then became swamps that collected the peat and formed the coal seams. So here we're at the bottom of the formation. If you go about 10 to 15 feet above the top of the Homewood sandstone, in most areas out there you'll run into the Brookville coal horizon, and here we have an entry going in at that horizon, and it's about I'd say half a mile from Falling Waters, and it's right along the CSX track. So this is like west of Falling Water Mansion. And if you go down in there, which I did, it's really very dangerous, and you know, I was like thinking to myself, what in the world? I tried to see if I could find a coal seam down there, and I didn't. And I think maybe this claystone that we're looking at is maybe under the coal. Maybe this was a clay mine. I don't know. There's like a 10-foot underclay in the Brookville here that we saw in our drill hole, so I'm thinking maybe that was it. But I went down there, and you can see in the little insert here, I got a close-up of the roof rock, and I was down in there, and it was like, this is scary. I'm getting the heck out of here. I mean, I was never so afraid, I don't think, ever being in a mine before, so I didn't spend much time. I got out of there. Here's a shot of the Brookville coal down along the Great Allegheny Passage near the Ramcat area, which is just to the west of Confluence. It's on the eastern flank of the Laurel Hill anticline. And you can dig it out there, and there's some really neat plant fossils right above it, and you've got a sandstone that's sort of deformed everything right above it there. And then if you go up towards Cucumber Falls at Ohiopyle, there's a picnic area above the falls. And in there they had some really nice deep mine openings. You could crawl back in there, and some really nice, well exposed coal seams. But unfortunately, those have now been sealed off. So, but still, at least I got a photograph of it. And this would be the Clarion coal seam right here that we're looking at in this photograph. Now here's that interval that I was talking about. We have the middle containing coal, and just right above it you have a brackish marine shale. It's got Dumbrella, Lingula sometimes in it. This particular location is not too far from the picnic grounds there above Cucumber Falls, but there's a actually better location to see it, and that's down along the rail trail on the western flank of Chestnut Ridge. And here you can see the Johnstown limestone exposed really well, and below that we'll see the Middle Quaternary shale, which has brackish marine fossils, and we're going to see that on the field conference. Another thing that was sort of interesting I noticed out there was the Worthington sandstone, which is a sandstone immediately below the upper Quaternary coal seam and below the Johnstown limestone horizon. And I think it was weathering out just like it was had a calcareous matrix to it, and I think that's because of the leaching of the Johnstown limestone and reprecipitation of that in the pore spaces there in the sandstone that's known as the Worthington. And then when it weathered out, it has this kartsty kind of look to it. And that's near Tharp Knob, just to the west of Ohiopyle, the borough of Ohiopyle. When you're trying to map the Allegheny Formation, and most places out there, sometimes the best you're going to do is these what looks like to be old drift entries that are still present in the landscape as depressions. Sometimes you get some spoil at the ends of them a little bit, and sometimes if you're really lucky you get like an abandoned high wall from an old mine to look at. But that's about as good as it gets, and those are few and far between, and those are even being reclaimed now as we speak in Ohiopyle State Park. I'd like to take a quick look at the top of the formation. Here we have the upper Freeport coal seam outcropping about halfway between the towns of Normalville and Indian Head on Route 381. This is like right near the axis of the Ligonier syncline. So you've got the Mahoning sandstone eroding down onto the coal right here, and that's forming the contact between the Glenshaw and the Allegheny Formation. Now I'd like to look at the Glenshaw Formation, which is right above. Okay, the outcrop belt's pretty much located around each one of the synclinal axes, and especially in the Ligonier syncline. Lithologically, even though the Glenshaw Formation shares some similar rock types than the Allegheny Formation below it, they are really different in that the Glenshaw's dominated by these brackish marine units that are persistent, that are very fossiliferous, and the Allegheny Formation in this area doesn't really have anything close to that. So also you get some red clay shales, and overall it's much more calcareous in nature, and the coal beds are a lot thinner. So if you're looking at the key beds in the Glenshaw, what's stands out the most is you get 4 main regionally persistent marine zones, and also you've got 2 sets of red beds, and the lower set is actually fossiliferous, which makes it very distinctive. And so we're going to look at some of those because those are the most interesting things, and those are like key beds that you can follow them around, and if you get enough of them, you can pretty much tell where you're at in the formation just by the combinations of the number of marine zones and the locations of the red beds. So the actual one unique key bed in the whole formation would be the red shale associated with the Pine Creek limestone known as the Myersdale red bed, and that contains marine fossils in it. All the other marine zones could be confused with each other in that they're black carbonaceous shales with coquina beds. They all sort of can look the same. Depositionally, we're looking at more of a marine setting. We have an interdistributary bay to a coastal plain to a lower delta plain. So we have the whole range of environments from lake deposits to interdistributary bays. And so what happens apparently is you've got these coastal swamps that start out as lakes, develop freshwater limes at their bases, silt up, become peat bogs on the swampy environment of the coastline. And then you have marine transgressions that come in and cover over these swamps, and then the sea starts to go back out, and gradually you get the more terrestrial sediments filling in over top of that again, like with plant debris and so forth. You'll find and mixed in with the some of the brachiopods, and then the same cycle repeats over again, where you end up back with the lakes and the swamps, and eventually another marine transgression comes in. And the best place to see these deposits and these beds are around the edges of the Youghiogheny reservoir. And you can see from this photo right here, this is taken, I believe, around September, mid-September, how low the water levels are, have been dropped. And this is a flood control dam, so every year they drop it as much as sometimes 60 feet below its normal level. So that exposes outcrops that normally are underwater most of the year, and because of that, they're underwater. There's no vegetation on them, and they're very nice. Then, as far as free from vegetation, you can examine them really easily. And so, here's the Brush Creek hole and Brush Creek Marine Zone, and this outcrops 5 or 6 different places along the lake shore. You can see really well a lot of cephalopods and various kinds of marine invertebrates, and I think we got some crinoids in there and some brachiopods. And so again, if you want to check out the different fauna that's in the marine limestones, this is a great place to do it because it's freshly the surfaces are renewed every season. Here's the Pine Creek limestone with the red beds I was talking about, and those shales, especially I think right in this area, are fossiliferous, so you can see that. And here's some here's a photo of the Pine Creek limestone. It's got a crinoid calyx and a gastropod preserved in it. Now here's another marine unit above the Pine Creek is the Woods Run Marine Zone, and that's also got a lot of gastropods. And again, just a really nice place to go examine fossils if you want to go collect fossils. What I used to do is we get a pontoon boat, and you can rent them, and you can just visit all these different outcrops around the lake. So it's really you can spend the whole day out there just looking at different outcrops and collecting fossils. We did a PA Geology article on it, and put together a map with locations of the different outcrops and identified them. And so it's pretty well. It's also, there's a calendar that shows you the water level and the average too, so you know what outcrops are exposed when. And so basically you've got exposure all the way from Mahoning coal all the way up through and including the Woods Run and Salzburg sandstone along the edges of the lake. Before we leave the Glenshaw, I just wanted to show you this is one of the only outcrops of the Glenshaw that you can actually see within Ohiopyle State Park on any kind of confident, reliable basis. It's the Buffalo sandstone, and it's outcropping and forming ledges around Tharp Knob and Kentuck Knob, and there may be some other areas. It litters the landscape, comes down the slopes, and it's like a coarse-grained, medium-grained conglomerate with angular pebbles in it. It looks for all the world like the Homewood, but fortunately it's high enough up in the section that you really have, it's not as bad as it could be as far as confusing it, but it is for that reason sort of a troublemaker, but there's always one. Okay, let's take a look at the Casselman Formation. And like the Glenshaw, it's also outcropping along the axes of the synclines. And I think the biggest outcrop belt occurs around the Youghiogheny syncline. Lithologically, it's a little more calcareous than the Glenshaw. But one thing it doesn't have is the major persistent marine zones like the Glenshaw does. It has one small thin marine zone above the Federal Hill coal right here, the Skelly, and sometimes it's only brackish, so it's not that persistent usually. So it's got, as far as red beds goes, it's got a thin red bed sequence. You find sometimes here the Birmingham reds, but other than that, not too much. The coals are thinner, and it's got a lot of fine grained rock in it, few sandstones, but mainly it's I'd say characterized by the coals just being a lot thinner and less persistent than what you see in the Glenshaw Formation. The best place to see it is in the spillway area of the Youghiogheny River Lake Reservoir. That's near confluence, and the base of the formation is defined as the top of the Ames Marine Zone. So you can go up, you can see the lower Grafton Sandstone, and you go up through the base of the formation here. You get the Federal Hill Coal, which is a Duquesne coal, and sometimes you can find brackish marine zone in this area right here. I'm not sure that I've ever seen it here, but it does exist in other areas. And then you can see a little more above it, but not a whole lot. And here's an outcrop in the upper part of the Casselman Formation, just east of Connellsville along the Great Allegheny Passage. And I've climbed up in here and looked at all the rocks all the way up through here and along this stretch of trail, and I cannot find anything at all that I can identify that's very distinctive. It's mainly just made up of siltstone, indescript, fine-grained sandstone, and it's all very micaceous. There's a few plant fossils, but other than that, that's all you see. Okay, let's look at the Monongahela Formation. And it's outcropping in the extreme northwest corner of the mapping area, and it's all to the west of Chestnut Ridge. Just a small outcrop belt up there. And the Monongahela Formation has 4 main beds in it: Pittsburgh coal, Redstone coal, Swickley coal, and the Benwood limestone. And the Pittsburgh coal at one time was called the most important mineral resource in the history of the world. It had a lot of economic impact in western Pennsylvania, and the town of Connellsville at one time supposedly had more millionaires per city block than any other place in the world. It's what history says. I don't know how true that is, but it was very extensively mined, and a lot of fortunes were made on it. Redstone wasn't as thick or as widespread, but it was still deep mined in places, as was the Sewickley. The Benwood limestone is about 100 feet thick, and it's quarried, all over Fayette County and in other areas. So it's an old lake deposit, and it extended all the way from Pittsburgh down to Morgantown, West Virginia, while the Pittsburgh coal was another huge, big, extensive deposit spread over several counties, western Pennsylvania and into West Virginia and Ohio. So you had a lot of beds and members there that seemed like they were very widespread in the Monongahela Formation, and they used to call it the productive. It was called the productive measures, and I think obviously the Pittsburgh coal was the main reason for that. But today, probably the Benwood limestone would fall into that category. So it's very important economically for the area. Depositional environment, like I said, the Benwood was probably representative of lake deposits, and the Pittsburgh coal, Redstone coal, and Sewickley were probably lower delta plain. The Pittsburgh coal, you can't really see any outcrops of it around Connellsville and the mapping area. You have to go just right outside it along the Great Allegheny Passage. There's a gas line that cuts across the trail right there, and go up along that. You can see there's a Fort Hill mine, and you can see where the pillars used to be. You can actually see the coal and where it's been mined out and where there's still a few pillars left. And you can walk around and look. There's a rider coal about 15-20 feet above that. You can see how it's subsiding down into the areas where the pillars where there isn't any pillars, where it's been mined out, and sort of get a good feel for what subsidence would be like at the surface. And right near that outcrop that I just showed you, this is what it used to look like. And as far as the Benwood limestone goes, there's not much in the way of outcropping, except for the one location at Robinson Falls, which we're going to see at the field conference, so I don't want to spend a lot of time on that right now. But it's not much of in the way of exposure for any of them. And the good news is we only have 2 more bedrock formations left to look at. And one is the Waynesburg Formation, and this is at the base of the Permian. It's the Pennsylvania Permian boundary, and it's up in the extreme northwest corner of this mapping area. And the other one is the one that's just above it, the Washington Formation, and that's also up in the extreme northwest corner. So that was the good news. The bad news is I don't really have any good slides of either of these formations to show you. The area that they outcrop in is heavily developed. So the only thing I can tell you is I know the Waynesburg and the Waynesburg A coal seam are mined in Fayette County. But other than that, I don't know too much, other than I believe they're limestones, especially up around the Washington Formation, that are pretty well developed. As you go up into section, especially when you get up into the Permian, it becomes more and more calcareous, and it's just mainly a lot of lake deposits and thin coals. And last but not least, the top of the stratigraphic section is the Carmichaels Formation. So before we go any further, I just want to take this opportunity to really thank Frank Pozzaglia for coming out here and helping us really understand the Carmichaels Formation like I never thought would be possible to do. He's spent a lot of time out here dating the various deposits and has brought his students out here and has done detailed mapping on the terraces and helped us just to tie everything together. It's really hard to measure the value that this kind of information will have for the general public out here and understanding the evolution of the landscape. And I know that the park personnel and everybody I talk to really appreciates all his efforts. So just wanted to thank him for all that work he's done out here. So the Carmichaels Formation represents old river channel deposits that now are preserved as terraces along the river drainage today at some distance above the current river level. And rather than talk to you about specifics about these deposits, because Frank Pozzaglia is covering that, I know, extensively, so what I'm going to do is just give you a little background as to how we came to map the Carmichaels Formation on Fern Cliff. And just to get you oriented, here's an aerial photo of Fern Cliff with the visitor center shown on the right hand side, and you got the Youghiogheny River flowing around its perimeter. The park, as I mentioned before, was interested in putting up a geologic display, so you can see here they got like forming Fern Cliff, and that was the decision they made, that they wanted to discuss the origin of Fern Cliff because they could see it very easily from the visitor center. So they thought that was something that they should try to interpret, and they got a hold of me, and I said, fine, I'll see what I can do. I wasn't really excited about the prospect of working there on Fern Cliff because it looked to me like it was, well, it's a meander bend in the river, and pretty much there's not a whole lot I can say about it other than, you know, the obvious stuff. But so, being a good geologist, I decided to go over and walk around and give it a try anyway. So I went over to the top of Fern Cliff, and lo and behold, I saw these round boulders laying on the surface, and I started to notice, I looked at, I saw this one that had like these white, flat, oval quartz pebbles in it, and I said, oh man, that looks like the long run conglomerate. What's it doing over here? And I thought to myself, well, that had to be transported down from Laurel Hill. There's by the river. There's no way it just occurred naturally. So I went around and looked at the area around Fern Cliff, right along the railroad tracks, and I was like, wow, look at this. This is the same stuff I'm seeing up there on the top of the cliff. And this looks a lot like what I remember the Carmichaels looking like over around Connellsville. So I'm finding more and more of it everywhere I look, and even found where it had looked like it formed a pothole on top of the Homewood sandstone. I was like starting to get really excited. I said, holy cow, I mean, Hickok and Moyer didn't show this on any of their maps, and they mapped the county, and as far as I knew, nobody else had ever mentioned it before. So I'm getting all excited and about this, thinking I'm going to really, really found something new nobody else has discovered. And then I made my fatal mistake, which was to go actually do some research on it. And of course I found that when Maurice Campbell was mapping those two folios just to the west, that he probably was staying in the Ferncliff Motel and probably out walking around and saw these boulders. And I think that may be what gave him the idea for one of his theories as to how those terraces were formed, which was uh, ice dams in the river, damming things up and causing the river to change its course. And even though I was crushed from learning all this, I still found a silver lining and took his ideas of an ice dam and put together a model for how Ferncliff might have originated, and actually made a pretty nice video out of it for the visitor center. Now, whether or not anybody's going to blow up a ice dam? No, Frank, don't light that dynamite.